Hello, everyone. Welcome to this overview video on the technical part of our project, a knowledge graph warehouse for neighborhood information. So this is one of the Theme 1 projects in the Proto-OKN program funded by NSF. So we have cross-disciplinary, cross-institution team working on this project. And then we also have a project partner from National Institute of Justice. So let me first start by a brief introduction of our team members. My name is Jing Gao. I'm associate professor in the Elmore Family School of Electrical and Computer Engineering at Purdue University. My research interests are mainly in data and information analysis, focusing on data mining. And my recent interest is with natural language processing, AI trustworthiness and efficiency, and knowledge graphs. So I will let other team members to introduce themselves.
Hello, everyone. This is Jingbo Shang. I'm associate professor in UC San Diego, working on computer science and data science. My research mainly focus on large language model, weak supervision, and information extraction.
Hi, everyone. My name is Dr. Daniel Semenza. I'm an associate professor at Rutgers University, where I'm also the director of research at the New Jersey Gun Violence Research Center. Much of my research focuses on gun violence prevention and intervention.
So Feng Long is not with us today. So Feng Long Ma is associate professor in the College of Information Sciences and Technology at Penn State University. So his research interest is in data mining, machine learning, and health informatics. In particular, he is interested in multimodal learning, medical foundation model, and AI security. So we have another video on the project overview, but here I will briefly mention the goal of the project. So our goal of this project is to leverage open source police data starting in select cities to collect incident level firearm shooting event information, then integrated with local neighborhood information. For example, we can collect census reports where the American Community Survey. We might have other data sources that we want to integrate. So basically, the idea is to have shooting data integrate with neighborhood information. And then based upon the information, we build a knowledge graph warehouse that help users easily navigate both aggregate and incident level firearm injuries and detect important patterns. And then the overview of the components in this project include the following. So the project centers around this normal data structure called knowledge graph warehouse. So knowledge graph is an interesting way of organizing information into entities and their relations. And then warehouse is an efficient data structure that organizes information along different granularities of location and time. So therefore, this data structure fits our data very well. And then our goal is actually to center around this new data structure and then develop components working on the construction, the utilization, and the maintenance of this data structure. So therefore, our project is divided into these three themes. So the first one, we focus on the construction. So basically how to convert the raw data different to this knowledge graph warehouse structure. So that requires go through several modules that include data integration and linkage, and then entity and the relation extraction. And then for some challenging components, we may need some key phrase generation strategy for the extraction. And then finally, we will organize everything into this data structure. And then the second theme is on how to utilize this knowledge graph warehouse once it is constructed. So this includes several modules working on the analytical processing, pattern mining, visualization, and interpretability. And then the third theme is on the maintaining of this knowledge graph warehouse data structure. So that involves components such as incremental update, this efficient querying, and standardization, extension, and integration. And then the final output or deliverables include both the data sets stored in this data structure, as well as the software that implement all these functionalities. And next we'll present the techniques overview from this software module perspective. So from the bottom, we first start with the different data sources. So we'll have multiple data sources with respect to the shooting events and the neighborhood characteristics. So we collect these data sources, and it first goes through this data integration and linkage layer. And then after that, the integrated data will pass to the knowledge graph warehouse construction layer, which include modules including entity extraction, relation extraction, multi-level aggregation, and metadata creation. And then after that, we'll reach at this maintenance layer, where we conduct several maintenance procedures, such as materialization, standardization, and incremental update. And then after that, we will have this warehouse operation layer, in which we will implement functionalities with respect to the querying and analytics of our data. So that includes some basic querying operations and some advanced analytic features such as pattern mining and comparison analysis. And then these components form the back end of this system. And then on the front end, we have a UI interface that interact with users. So users can express their interests and then input queries into the system. And then through components such as visualization, summarization, and some interface design, we can properly display the results. So give the knowledge and the insights present back to the users. So next I will pass to Jingbo to talk about some details about some of our components.
Sure. Let's take the city of Philadelphia as an example to go through how we get this knowledge graph warehouse constructed. So if we go to this Open Data Philly website, we will be able to find multiple sources for the data, and one of them will be the shooting victims. That includes majority of the shooting events we're looking at. And it has a nice breakdown of all the things, and you can see some details at the bottom left. There's a spreadsheet showing you all some details here. And next page, we will see another way of the data you can observe is the census tracts. And it actually includes a lot of information about how the demographic information distribute in different places. So the number one challenge we have here is how can we integrate these different data sources together and put them together in a joint sheet. So the next page will show you that we actually mapped the location of the shooting to the census groups by their longitude and latitude information. We matched the polygon of this different census group and then augmented the data frame into one form, like merging two together. And then you will see some details here. We have all the necessary information to build a graph. But before we really create a graph, we need to do some normalization and making sure we're talking about the same information and try to group them together into nodes. So on the next page, we summarize the major challenge as a heterogeneous data sources, and we actually have different values. For example, on the previous page, you may observe that for the one place, you may see a particular body part, or it will show you multiple. And for the date and time, those kinds of things, sometimes people have months first, sometimes people have day first, and they also have some time zone diff if we're looking at different records. So we need to unify all these different formats and make sure they will be unified using the same keywords. And there are also some synonyms. We did some NLP technique, try to apply some natural language things to recognize those synonyms and merge them into the same nodes. And we also apply some granularity things. For example, we can go down to a street. We can also roll up to some region, maybe zip code, maybe even larger regions. So this granularity were also taken into consideration. And there might be some duplicated events if we're looking at events from different sources, from police records or hospital records. We may see the same events happening in the same location, similar time. There might be a slight offset in time. There might be some slight difference in location, but we try to group them from some clustering techniques, and we treat the location plus time as a primary key, assuming there won't be too many similar events happening at the same time and the location. So that's kind of a way we aggregate the information together, and then we will end up with a very nice knowledge graph. So if we go to the next page, we'll see an example, like everything is centered at the shooting incident, and we will have the address, the location, and the time, and the race group, sex of the victim and age one, and also the officer involved, all this information, and then we will go down to different granularity and find a very nice graph on the right hand side. And just looking at the data we have in the city of Philadelphia, we will have hundreds of thousands triplets and tens of thousands unique nodes and attributes and different relationship types. We categorize all the things, and we also discuss with the Frink team together to make sure we are reusing the necessary schema can be shared with other teams too. So at the end, we have 12 different types of relationships. So that's pretty much all the example if we look at the city of Philadelphia. So Jing, maybe it's a time to talk about user interface.
Sure. Thanks, Jingbo. So that's actually our backend where we conduct the knowledge integration, the data integration, and then convert the data into this knowledge graph representation. And then on the front end, so we develop a user interface where user can navigate the information easily through the map display as well as a chatbot query interface. So next, I will talk about the technique underlying the interface design. So our interface is currently hosted on Amazon Web Services, so it's publicly accessible. So first of all, we have different functionalities available with respect to map display and visualization and the selection of the data sets. So for example, we can display the heat map of the shooting events on the map. So basically, what we did is map the incident based on the location information, and then visualize the information based on heat map. And then we have this incidence trend analysis. Basically, we can use some bar charts or some other plots to visualize the trend, for example, in the counts of the shooting events. And then users can also use some map functionality. So for example, zoom in, zoom out. And then once user navigate to a fine-grained location, so then user click on a certain incident, and then we can display the detailed information of that incident. And then user can also click different areas, and then we can aggregate the information with respect to those different areas. And then user can also, we also provide the interface for user to choose different parameters, different variable value ranges, and then we can display the information correspondingly. So basically, these functionalities are mainly implemented by querying on our database, and then aggregation or summary on the corresponding data, and then integrate with this map display functionality. And then more interesting aspect of our interface is the integration with the chatbot. So we have an interface that have two components. So the right-hand side is this chatbot functionality, and then the right-hand side is the map display. And then basically this is a two-way interaction. So on the left-hand side, user can input user query, and like ask about information regarding certain location, certain time. And then the right-hand side, the chatbot will return the query results, will summarize the query results and display it for user. And correspondingly, the right-hand side, the map will display the corresponding information on the corresponding areas. And then on the map side, so user can do some filtering, some querying based on some variables, for example, like the time, and then some other information like some attribute of the shooting victim, and then whether the shooting is fatal or non-fatal. So choose some variables to do the filtering. And then we not only display the filtering results on the map, but also can display the text summary of the results. So this two-way integration, so basically is implemented by the following. So if we consider the first way, so where user input a query, and then once user input a query, so we will use this underlying large language model to first transform the query into Sparkle query. So then the Sparkle query will run on our data and then return the results. And then we will go through the large language model again to formulate a nice text summary. And then from the map side, so once we conduct a querying on the database, we will also construct a query to the map area. And then that query will be sent to the map, and then map will change the display accordingly. So basically here we demonstrate this snapshot on this user query and map display update. So once the user input a query, and then we will basically output a test summary as well as those incidents on the map that correspond to the user query. So basically the underlying technique is a combination of the use of large language model, properly formulating the prompts, and then the interaction with the querying on the database and then the querying on the map. Okay. So that's all for the technical overview. So we are still implementing some other functionalities about the project. So for example, right now we not only have Philadelphia data, we are also including Chicago data. We also plan to integrate more data sources into the project. And then once we get more cities data, we also plan to have more functionalities. For example, comparison across data from 2 cities. So we are keep updating our project. So please refer to the project website for the latest updates. And then on the project, we also have the prototype website there, so you can click on it and try out our prototype. And then on the project, you can, on the website, you find more information, for example, the description, and then the team member about the project. And then we also have another video on the project overview. And then please check out that video for more the background, motivation, as well as impact of this project. Thanks again for watching this video. So that's all.